Good morning. We are the presenter of this particular topic. I am Marian Hasmin Tukasan, together with my partner Mekaela Mina. So this is the contents of our topic. First is the definition and highlights of medieval period. Next is the philosophers, Euler, Descartes, and Fermat, and lastly the conclusion. So in medieval mathematics, there are texts that are recognizably devoted to arithmetic, geometry, or algebra, but most of the writings were concerned with the astrology and astronomy. Paris and Oxford holds major collections of medieval manuscripts, mainly with mathematical content. Medieval Europeans also believed that mathematics provides the basis to understand the created order of nature justified by Plato. Who is Plato? Plato wrote about the account formation of the universe and by biblical passage in the book of wisdom that God had ordered all things in measure, number, and weight. So let's move on to the philosopher who contributed mathematics in medieval period. First is Euler. So who is Euler? Euler is one of the founders of pure mathematics. He not only made decisive and formative contributions to the subject, but also developed methods for solving problems in observational astronomy and demonstrated useful application of mathematics in technology and public affairs. Also, Euler carried integral calculus to a higher degree of perfection, developed the theory of trigonometric and logarithmic functions, and last, reduced analytical operations to a greater simplicity. So here are the examples of Euler contributions. Euler's integral calculus to a higher degree of perfection, Euler's theory of trigonometric and logarithmic functions, and Euler's reduced analytical operations to a greater simplicity.
So, hello class, as a continuation to the report of my co-partner, which is Marian Takazon, we will proceed to René Descartes. So, do you know René Descartes? If you don't know yet René Descartes, I will discuss some important information about René Descartes. So first, the details a groundbreaking program for geometrical problem solving, what he refers to as a geometric calculus that rests on a distinctive approach to the relationship between algebra and geometry. So as you can see in the PowerPoint, that is the work of René Descartes as listed. So the contributions or the major contributions of René Descartes are listed as follows. First, his most significant achievement was the use of algebraic formulas to describe geometric figures which form a branch of mathematics known as analytical geometry. So as you can see, all of us know René Descartes as a father of algebra. However, we don't know that the significance of algebra and geometry has been contributed by René Descartes. So that is the first major contribution of René Descartes. Secondly, he is the founder of a Cartesian coordinate system, which is the x and y coordinate, which portray a three-dimensional shape such as cube resulting from an algebraic formula. So we have a two-dimensional shape that categorized. It is the triangle or the square, and we have the 3D shape which is the cube, the sphere, the cube, the cone, and etc. So all of those three-dimensional shape has been contributed by René Descartes as follows in the coordinate system as x and y. And the last one is his most significant contribution was bridging the gap between algebra and geometry. As I stated from my first phrases, that the major contribution of René Descartes was bridging the gap between algebra and geometry. So the mathematics that we enjoyed between algebra and geometry has been confounded and has been created and researched by René Descartes. Secondly, we have Pierre de Fermat. Pierre de Fermat was a well-known mathematician in the 17th century in France during the medieval period. So our topic for today, as you know, as instructed from the very first beginning, is about the medieval period during those time of these mathematicians. So lastly, we have Pierre de Fermat, or also known as the mathematician in the 17th century in France. These are some informations about Pierre de Fermat. 1. The biggest claim that Pierre de Fermat has to mathematical fame is that he is well known. He is well known for work on number theory and probability. So, do you ever encountered number theory and probability when you are in grade 9, grade 8, or grade 10? If you haven't encountered it, I suggest that you study it, or better, you make some research about it because it's a beautiful topic about mathematics. So, what are the famous contributions of Pierre de Fermat? If you don't know, I will tell you what is his major and beautiful contributions about the mathematics, about the development of mathematics during the medieval period. First, Pierre de Fermat contributed the last theorem. What is last theorem? It has a no whole integer solutions for a number that is greater than 2. So the formula for that is x raised to the number plus y raised to the number and equal to z raised to the number. Secondly, we have the Fermat-Little theorem as stated in the presentation. You can see all of those contributions, and we have the second one, the Fermat's Little theorem as stated. So as you can see in the picture, it's a little bit complicated as you can see, but when you study, I know when you study all of those or do some research or you learn how to love those topics, you will probably love all of them. You will probably love solving all of them. So the next contribution, major contribution of Pierre de Fermat is the Fermat made contributions in many areas of mathematics such as probability theorem, analytic geometry, optics, and infinitesimal calculus. So when you are in college, you will encounter some major topics about calculus, about geometry that will somehow makes you brainstorm, makes you think and love math deep because it has a lot of branches, it has a lot of theorems, postulates that you will encounter, but probably you will love all of them, I swear. And the last one, contribution of Pierre de Fermat, is the Fermat's principle. All of us has our own principle in life that could be about studies, about teaching, about life, about something that we love to do or that motivates us. However, Fermat also has a principle, and that principle states that the path between 2 points taken by a ray of light leaves the optical length stationary under variations in a family of nervi. So that Fermat's principle is what we call the Fermat's number. So all of those Fermat's number contributed in the development of mathematics during the medieval period. So I can discuss to you about all of those discoveries about Pierre de Fermat and René Descartes because I am here to discuss the mathematical development during the medieval period during about all of the contributions of these mathematicians. However, if you wanted to learn all of them, you can search, you can browse, or you can make some study about these topics because it's beautiful. If you understand or try to understand all of this, you will probably love mathematics. As our conclusion, we have provided 3 minutes video about the mathematical development during the medieval period. So I hope that if we didn't stated that much concisely, clearly, or briefly about the development of mathematics, I hope this video may find you well, and I hope you will catch up or learn something about this. So enjoy and thank you for listening.
After the mathematically frugal age in which the Greeks lived, there came a millennium of relative stagnation. Discovery was few and sparse, and generally was concerned with pointless debates. Ad absurdum, how many angels can stand on the point of a needle? A classic argument against the reasoning of the time. In the millennium that we call the Dark Ages, most Western mathematical knowledge was limited to translations by the Roman senator Boethius of the ancient Greeks. He had coined the quadrivium, the 4 subjects that he felt were necessary to study to understand the mind of God. These were arithmetic, geometry, astronomy, and music. Mathematics was used to explain nature, as was believed by Plato and the Pythagorean cults. The end of this stagnation was marked by newer investigations into ancient mathematics. Adelaide of Bath and Robert of Chester provided new translations of Euclid's Elements and a never-before-seen introduction of Al-Khwarizmi's Book of Algebra. This marked the spread of mathematics in Europe. The first great medieval mathematician was Leonardo of Pisa, also known as Fibonacci. He had traveled to the Almohad Kingdom in North Africa as a child, and there he learned and eventually spread to Europe the Hindu-Arabic numbers. Although anything Arabic was viewed with suspicion, these numerals were far less clunky than those of the Romans. One of his more famous ideas was that of a sequence, where every term equaled the sum of the previous 2, the Fibonacci sequence. This came to him when he studied successive generations of rabbits. The ratio between successive terms approached, as was discovered, a very special number, the golden ratio. His mathematical knowledge was recorded in his Book of Calculation, or the Liber Abaci. Even hundreds of years before the likenesses of Newton and Leibniz, the fundamental ideas of calculus were being grappled with. 14th century calculator William Heytesbury attempted to measure instantaneous speed as, by the path that would be described by a body, if it were moved uniformly at the same degree of speed with which it moved in that given instant. That is, the tangent to a curve of displacement. Similarly, the distance covered due to uniform acceleration, later solved by integration, was solved as follows. A moving body uniformly acquiring or losing that increment of speed will traverse in some given time a distance completely equal to that which it would traverse if it were moving continuously through the same time with the mean degree of speed. The dissemination of Greek text and knowledge from other parts of the world helped to bring the intellectual stagnation of Europe to a close. People began to observe the world directly and explain empiricism with mathematics. This could be said to be illuminating the West.